All right, guys, so back again from the Zoom interruption. So as Ms. Wilson was saying, we can factorize the denominator, which is y squared minus 4. But can the numerator be factorized? Ms. Wilson, you think that you don't think that you don't think that a numerator can be factorized?
So only by 1.
Okay, all right. Now, all right, so what you need to remember though, Ms. Wilson, is that the numerator is a 4-term expression. And so you may be able to apply grouping method in factorizing it. So you probably want to try grouping if that's possible. All right, so what we will want to do in such a situation, we may want to factorize, since the grouping process is a little long, we may want to just do that factorization in a rough work sense first. And then whatever we get as a result, we will put it as the numerator. So if we take 3xy minus 6x plus y minus 2, it's a 4-term expression. So if we apply grouping, can we identify pairs of common terms or pairs with common factors? So the first pair here, what would be the common factor for that first pair?
3x, sir.
All right, so we can use 3x for our common factor. Open our bracket. So 3x into 3xy give you
Y.
And the 3x into 6x give you
1, sir. Minus 1.
Minus 2.
Oh, yes.
All right. Now for the next term, which is y minus 2, for the next pair, y minus 2, what would be the common factor?
1.
1. All right. So when there's no obvious common factor, use 1. So we have 1 into y, give you y. 1 into minus 2, give you about minus 2. Next, what we do?
Pull one of the y minus 2, sir, and then group the 3x plus 1.
All right, so we have y minus 2 as a common factor, and then we group 3x plus 1. All right, so when we factorize our numerator, that's what we get. So if we put this back in the numerator as the factorized form, so we'll get y. So I'll get y minus 2, close brackets, times 3x plus 1, close that bracket. Now, for the denominator, so this part here would have been the factorized form of the numerator, right? Now, for the denominator, what are we going to get? So we factorize y squared minus 4. What will this give us Now, Miss Waysome,
Yes, sir.
we factorize the denominator, what we get?
With the y, that would be y minus 2, sir.
All right, so first we write all that we can write in their square form.
Mhm.
And here we would have now a difference of square. You remember how now to factorize difference of square?
Yes, sir. So
Right.
y,
The open
y,
brackets,
y,
put their bases in.
we need to them to turn.
And what next?
Put a plus and a minus in one bracket, sir.
All right, good. All right, so we would have gotten now for the denominator in the factorized form, we would have y plus 2 times y minus 2. All right, so now can we factorize anything? Sorry, not factorize. Can we cancel anything?
Yes, sir.
All right, so what can be canceled?
Y minus 2 with y minus 2.
All right, so we cancel y minus 2 with y minus 2. And that leaves us with what?
3x plus 1 over y plus 2.
All right, so that's what we get by simplifying this fraction in its simplest form. All right, so just be reminded, look carefully to see if your expressions in the numerator and denominator, if they can be factorized. You do those first, factorize them, then you cancel by looking for like expressions in both the numerator and the denominators. Is that clear to everyone? Raise your hand, let me see. All right, so here's some clarity. What about you, Miss Green?
No, sir, I'm confused.
Miss Green, what are you saying just now?
Sir, I'm saying I am confused.
Oh, you're confused.
Yes, sir.
All right. What is the part, which part of it is confusing for you?
Sir, what about y minus 2? Let me get the answer from you, sir.
Where we get the y minus what?
Y minus 2.
In the numerator, when we're factorizing the numerator, that's the one you're asking about?
No, sir, over there, so we have y minus 2 in the bracket and 3x plus 1.
And 3x plus 1, oh, we get it from what we get down here when we factorize the numerator. So whatever we get after we finish factorizing the numerator, we put it back over here in the numerator. You follow?
Yes, sir.
And then now, after we factorize the denominator, what we get as the factors, we put it now in the denominator. You follow?
Yes, sir.
Right, so that's what we did. So we took the numerator and factorized it, and then whatever factors we get, we put it back in the numerator. We took the denominator, factorized it, and whatever we get, factors we get, we put it in the denominator. Then we cancel like expressions. All right. Now, why we factorize these in a rough work sense, because the factorization would be a little long and it would take a little process in order to get to our product. So we would have to do that separately in a rough work sense and get our factors and then rewrite it in the numerator. And the one for the denominator, write it in the denominator. All right, so that should be clear to you now. Anybody else? Everybody is clear? Ms. Cavero?
Yes, sir.
Okay. Mr. Bartley?
Yes, sir.
All right, I realize that these days you choose to be silent in my class. I'm not sure why, but maybe because you're not as frequent as you used to be. All right, so everybody should be good with this one. So let me clear what we have on the screen and move on to our next example. All right, so this is what we would get when we factorize our numerator. So these are the factors for our numerator. When we factorize our denominator, these are the factors. So we rewrite our fraction, put in our factors for the numerator in the numerator and those for the denominator and the denominator. Then we cancel like expressions. All right, here we have another one now. Could you try this one, guys, and tell me, I'll just give you about 5 minutes to try it, and then we'll see what we get afterwards. All right, I'll give you about 5 minutes. Try this one. All right. Anybody figure out what to do and would like to walk me through the process? Ms. Waysam, you want to walk us through this one?
Not through as yet, sir.
Okay. All right, just raise your hand when you're finished and let us go through it together. Okay, then Ms. Wilson, you can walk me through the process now. So let us factorize the numerator and denominator separately and apart first. So for the
Yes, sir.
numerator, what you get?
All right, so for the first part, sir, 4x squared minus 9, sir, I'll break it down. So it will be 2x squared minus 3 squared.
All right, so we have 4x squared minus 9. And when we write that in their square form,
2x squared minus 3 squared, sir.
2x all squared minus 3 squared.
Yes, sir.
We factorize it.
Yes, sir. When we factorize, we get 2x plus 3 in one bracket.
We put down the bases in the brackets.
And then 2x minus 3 in the other bracket.
Then you put a plus in one
Minus.
bracket and a minus in the next bracket. All right, so that would give you our numerator.
Yes, sir.
Those are the factors for our numerator. So we can just rewrite our fraction expressing our numerator in the factorized form. So we would have
2x
2x
plus 3
plus 3
in one bracket and 2x minus 3 in the other, sir.
All right, let us now factorize our denominator.
Yes, sir. 4x squared plus 12x plus 9. So I use the AC method for this one.
All right, so our denominator. Wait a second. So the denominator. We're factorizing 4x
12 plus 12x
plus 12x
plus 9.
plus 9.
So I use the AC method.
All right, so use the AC method.
Yes, sir. 4 times 9.
Now the AC method, just give me the factors that you get.
6 and 6, sir. So it would be 4x squared.
You get what?
4x. You mean the answer, sir?
I'm talking about the denominator. What you get for the factors?
2x squared plus 3 squared, sir. 2x plus 3 all squared. Sorry.
Okay, so you get 2x
Plus 3 all squared.
plus 3 all square. All right, so that would tell you that this is a perfect square. And if you had used the perfect square method, then what you would have done is to write the 4 in its squared form. So you would write that as 2 squared. And so if you write in the 2 squared x all together, you would have 2 squared x all squared. Then you write back a middle term, which is 12x. The last term in its squared form would be 3 squared. All right, now you would probably want to check to see if the middle term works out. So you multiply the 2x, so you take the base of the first term, which is 2x, times the base of the last term, which is 3. So you multiply 2x times 3. you get 6x, and then you times that by 2, and you will get the middle term, which is 12x. So that would tell you that you have a perfect square. Once you get back the middle term, when you do that, you have a perfect square. So once it is a perfect square, you just bring down the bases in brackets. So this is how we factorize it. Bring down the bases. So you bring down the 2x. You bring down the 3. And you keep the sign of the middle term. And then outside the bracket, you put your square. All right, and so we'll get this factor that we have up here, just the same. Now, the advantage of learning this method is that it's a little shorter, or should I say it's a lot shorter than using the AC. But if you use the AC, you will arrive at the same answer. All right, so with that said, our factors for the numerator, 2x plus 3, bracket 2x minus 3, and then in the denominator, 2x plus 3 all square. Now, can we cancel any like expressions here?
Yes, sir.
All right, so what are the like expressions?
2x plus 3 with 2x plus 3 all squared, sir. So that would leave us with just 2x plus 3 in the denominator.
The square would cancel out there. So in the numerator, we would have a 2x minus 3 over the denominator, which is
2x plus 3, sir.
2x plus 3. All right. And it ends right there. Don't make the mistake and do this. Cancel this with that. Remember, that is illegal. You cannot take out part of an expression and cancel it with another part of another expression. All right, guys? Don't make that mistake. All right, so everybody is good with this. Raise your hand, let me see. All right, so let me clear what we have here. Now, so this is what we would get for our answer. Now we have these questions that I would like you to try, but you wouldn't be able to try them within the time that we have now. So I'm going to ask you to just take a screenshot of these questions. I think we have some more too as well, but take a screenshot of this screen, then I move it on to the next screen, and you will take a screenshot of those. And then now you can try those for homework. A matter of fact, you should be able to access these questions on the website because they are in the class notes. So you go into class note 1, you look for algebraic fractions, and you look for the assignments, and all of these questions are there. So if you are unable to take the screenshot here, you can find them on the website. All right, so you finished taking a screenshot of this slide, raise your hand. Can I move on to the next? All right, I'm going to move to the next slide now, guys, because I only see a few hands. I don't know if everybody is already finished. Ms. Cavero, you finished?
Yes, sir.
All right, Mr. Bartley, Mr. Lamar.
Yes, sir.
Yes, sir.
Darty. All right, next slide now. Take a screenshot of this one too as well. Just let me know when you're finished. All right, Mr. Lamar, Ms. Wilson, Cabrera, Starty. All right, I guess Ms. Green might be busy. Take a screenshot of this one too as well. And then raise your hand when you're finished. All right. All right, so everybody would be finished with these now. All right, so these are the questions that I would like you to work for homework. Now, as I said before, if you are unable to take the screenshot, there's a worksheet on them in class notes 1. You're just going to class note 1, look for the topic, algebraic fractions, and then look for the assignment. Click on the assignment and you should be able to see this entire worksheet there. All right, Mr. Lamar asking a question?
No, sir.
All right, you can lower your hand then. All right, so I'm going to stop here for today, and then we'll continue next class. Which on this topic we'll continue next makeup class, which is next week Monday. And for your Easter break, guys, we're really not going to take a break in the Easter, so we'll have class the usual time throughout the Easter. All right, guys.